simple file IO operation in the read-write mode. So we are opening the sample.txt in read-write mode. We are reading the file and we are closing the file identifier. And so file.read is all your entire paragraph is stored in text object. Just I randomly open a website. In a website, I just copy pasted one paragraph in a simple notepad file and save it as a .txt file. So if you quickly read this paragraph, it's something related to computer vision, isn't it? Computer vision is not just a way to convert pictures to pixels. When you do the data preparation for the text, it is very important to understand what you are going to do with the text. That is very important. There is no one standard pre-processing approach for all applications that you should be aware of. So I broadly classify the applications for the text into two major areas. One is sequence modeling. Okay, one is for the sequence modeling application. Can you make a guess? What could be the other? Sequence modeling application means your model is going to understand the sentences. It is going to understand the meaning of the sentences. No, don't get confused. Not this sequence versus functional. We are not talking about that. Please don't get confused. Not this. The sequence means it is a time series I am talking about. It is a time series sequence. Not about your deep learning sequence model and functional design. I'm not talking about that. This sequence referring to the time sequence.
That is it like text to voice conversion, text to signal time.
Yeah, everything will come under sequence modeling. Okay, when I give a text means the text is going to represent it in a sequence, right? Suppose I'm giving a text.
Or the occurrence of particular keywords.
See, the cat which actually ate few apples. Was what will be the likelihood word here to be predicted here?
Sick.
Yeah, it could be a sick.
Hot.
So your sequence model is going to find out, okay, if the word sequences, these are all the sequences are there, which token is going to have the highest probability. Okay, in what way you have trained the sequences? Suppose this is the sequence will come. Which word is going to have the highest probability? That means in your sequence modeling, finally your time series, your recurrent neural network model, your output layer is nothing but a rich vocabulary, tokens. Okay, so which token, the probability it is going to get, it's one hot encoded, equal to the vocabulary size. Okay, so for these things, which word should take the highest probability, it will try to fill your sequence modeling. So the moment I say sequence modeling means your model actually understand your English sentence, the meaning and the context of the English sentence. Okay, it could be like sick or any other contextual meaning. The cat which actually ate few apples was full. Okay, already they are full. Their stomach is full, something like that. So the model has to understand how intelligently to understand the context of the sequence. That is what your sequence model try to capture the word sequences.
The other one is classification.
Very good. And okay, in people used to do it for the classification. Early days, they used a separate feed-forward model for the classification, and they realized it better to use for the classification task also. It's part of the sequence modeling they brought it. This text as a classification problem. I have to focus only on the keywords. Am I right? Keywords. But for the sequence modeling, I should not focus only on the keywords. The entire sentences, the entire word tokens I should consider. That is a basic difference. Only I'm focusing on the keywords. What are all the keywords? Imagine if it is a movie review, or it's any restaurant review, or it's a food review, or whatever it is, it will look for only the keywords. Okay, taste, okay, awesome, mind-blowing, wonderful. If these are the key tokens, okay, if these combination of the tokens are there, your model will already trained for the higher probability belong to one class. Okay, maybe good, a positive sentiment, or the other set of tokens like negative tokens, like very pathetic, disastrous, like this. It is being taught to some negative sentiment like this. However, they were happy with this. Using a even simple feed forward model also, you can make use of it, because the order of the words doesn't really least important, isn't it? At the end of the day, your model is going to look at, okay, if the keyword taste, awesome, mind-blowing, wonderful means that review of the hotel or the review of the restaurant is good. It is going to understand. But few cases, suppose if the sentences, okay, you might have seen some of the times people are using a sarcastic comments, sarcasm. So if there is a sarcasm in their feedback, sarcastic command and all, with only the keyword alone, okay, sometimes your feed forward model may mislead what actually the customer is trying to communicate actually. So in a lighter note, yeah, you can do a classification task even with the feed forward model itself. After all, we are looking into the key tokens and we are making a decision. Apart from classification tasks, you just think about your Amazon and the popular e-commerce portal are doing a recommendations, right? These recommendations models, recommendation engines, how they work, it's simply based on distance-based calculations. Imagine if you are going to recommend a similar product to the customer. Okay, if a customer is particularly viewing a particular product, and that particular product having a description, product description, okay, the product description having a certain key words, okay, the keywords alone I'm important, okay, display, Okay, display, RAM, memory, okay, memory, amyloid, okay, amyloid, battery. The moment you look at the key tokens, you understand the product is related to mobile phone, isn't it? Product is related to mobile phone. That too is related to amyloid display, and some understanding we understand. But here, all the English stop words like is, of, preposition, conjunctions, there, or, okay, also, for, then, all these things is not important for me. What we call these words as English stop words. All your preposition, conjunctions, and all, it's not important for me. Only the keywords are important for me. Okay. It's all depend upon what kind of application you are going to build. For sequence modeling, the entire sentence sequence is important for me, including the grammar, the meaning, adjective, adverb, everything makes sense for me to understand the context. I should actually keep the entire the sentences as it is. I have to prepare. Only thing is what the punctuations, the comma, exclamation, these things has to be clean. Otherwise, the entire sentences I need to understand to comprehend the meaning of the sentence, isn't it? So, if you are going to build a simple recommendation system based model, your key token alone sufficient. On other hand, if you are going to build a classification model using a feed forward model, I'm telling you, using a feed forward model, even still with the key tokens, you can train the model with the key tokens, and you can see whether if the tokens belongs to this, then it belongs to not only for the sentiment, I'm telling you, even you for the any text classification. Some newspaper article, suppose a news article you wanted to classify, some news article, you need to classify the text. Suppose your model will see some key tokens, a political, party, okay, cadre, okay, cadre, a meeting. The moment it look at these things, already I have trained the model. This is the news article about some political news. Okay, political news. If on the other hand, if the model look at some of the key tokens like actor, movie, Bollywood, song, hit, something, these tokens, it's going to recognize this is a it's entertainment news, and I can classify the text as a sports news. I can classify the text as a science and medicine news or religious related news. So such kind of just simply I wanted to categorize the text. The actual sequence of the sentence is not important. Only I can extract the key token is more than enough for me. But the moment I say sequence modeling means the actual sentence flow is important for me. In which order the words I'm writing the sentence, that is very important. So in broadly, I'm categorizing the text-based application as, are you interested to capture the actual sequence of the sentence is important for you, or just the key token alone is enough for you to understand and comprehend what is there in the text, just like a classification task. As mentioned by I think Vijay, or who told classification at the beginning, we can even use a classification task with the feed forward model. But sometimes when the customer gives a very sarcastic command and all, the complete the context also I should understand. To understand the context, the order of the word also very important. Okay, you wanted to train such model with the complete the sequential. Even nowadays, the sentiment analysis was people are started using specifically the recurrent neural network. So for content classification and all, you can very well use the feed forward model, or even simple distance based model also you can very well use. Simply you wanted to classify the content of the text, whether it is a mobile phone, or whether it is it's a food product, or it is a baking product, or it is the dress materials, or so it's going to merely tell what is the content, we are talking about. Yeah, spam or ham. This again comes under the classification. So broadly, we can divide your application into, okay, just as a, you are going to classify the text, or you are going to build a sequence modeling. For the classification task, okay, the sequence order is not important. I can clean all the English stop words, I can clean. But for the sequence modeling, I should not clean the English stop words. I should not clean the actual sequence. I have to maintain it. So that's the difference. However, we'll see one application I will demonstrate for the simple classification task. How do we prepare the data, and how do we accomplish the classification task? Then we'll be moving on to the sequence modeling. For the sequence modeling, what sort of applications we construct. So this category also we have one exercise, and for this category we have multiple exercises.
So one question, is text summarization the combination of both? Like we pick up keywords and we try to form a sentence, right? So is it the combination of both or sequential modeling?
Sequence, purely sequential modeling.
Okay.
Purely sequential. Because what you wanted to summarize, that is being actually taught to the model. Okay, what you are going to summarize, actually the complete input sequence and output sequence you have to talk to the model. So this is one full paragraph. Okay, the full paragraph. For this is a summarization. This will be given as the complete input sequence to the model. Model will be learning this input sequence, and the summarization. What is the sequence of words? This completely is given to this.
Yeah. Can I have even keywords added, sir, that I want regarding this topic in my summarization? Because if let's say if the document is huge of pages, so can I have that parameter in this part?
Obviously your summarization, what will be the nature of this output? The nature of the output will be based on the keywords only, right? That is how you capture it. So obviously your sequence model will naturally learn it, how to capture the keyword. You no need to directly tell that, hey, this is the keyword. That is speciality of the model, is to understand where is the context. If I talk about this, how the context is coming, how to capture, how do I know the context of the sentence? Which portion is less important, which portion I should focus on? Your LSTM model is going to learn it.
Okay.
So obviously your summarization is going to be the keywords. TensorFlow has certain conditions, or I can say rules or protocols, because to maintain the structure and the backend, everything. That is the reason you may wonder that why model.fit is they don't have the metric other than accuracy, because anyhow internally the cost function is being your gradient descent is being done based on the loss function only. This is monitoring is just for our convenience. During each and every iteration is going to calculate accuracy or F1 score is for our convenience. We are asking the model to print that value. In case if you train the model using other than any of the default one, while we have some issues will happen while saving those things in the form of a model. Then you may ask the question, then how do I know that whether my model is working well in terms of other metric and all? That is why, that is the reason always you validate, you are validating the model with your validation data set. You are validating here separately your understanding. Are you happy with the overall average effort score, or which category your model is misleading and all. Based on that, you go and tune the model. So better, I would always appreciate, even though you display the values, okay, where you will face the challenge is what, when you try to save it, it will save it, but we have some issues if you change your user defined metric during your model training or something like that. That hy file function will not have a representation for other metrics other than the default one. I think same scenario will be there for if I change my monitoring process other than the accuracy. Okay, if I change this to loss, I'm a bit doubtful. However, successfully saved it, but let me try to load this plant 4 VGG16 best file from the DL. So I hope it is prepared that file for me. Yeah, so plant 4, right? So plant 4. So it is created, it has saved it. But let me load and see, is there any issues or not? Successfully loading or not? Plant 4 VGG16. So plant 4, this time I'm going to load as a trained model. Some amount of overfitting is there. However, we have to control it, but let us quickly see the model performance. Plant 4. So my validation data, I'm going to validate the plant 4 model. I have trained using Adam. Okay, with Adam it tends to overfit. But yesterday I trained with not with Adam. I trained yesterday. I used SGD. Hope you remember SGD. But let us see the performance of this. Because when you tune the last 6 CNN layer, it tends to overfit. Okay, that is the observation we could see here. Trained model.predict xval. So I do the ypred. So compare your ypred with the actual label. All the ypred I convert to argmax and I convert the label. I compare with the actual label. Actual labels also one hot representation, right? Yval. So the one hot representation also I converting back to the integer label. That is in y actual, and this is the ypred. From the predicted probability, I'm converting to the label. That is, these are all y underscore label is the predicted label, and y underscore val is the actual label. Now I see the classification report for it. So it's a very bad score I got. So 37% for one class. SGD. This itself was giving me the better performance. So if I load plant 3 was a different architecture for plan 3, I load as a trained model. Okay. So the trained model dot predict your validation data YPRED. So those YPRED I convert to labels, comparing with the actual labels. Look at the 0 labeled record, 37 F1 score. Sorry, this one. So plan 3, I just store it within 5 efforts. It's underfit model. On this guy. It's just it was trained for only 5 efforts. Let me check with plan 2. Plant underscore VGG. Was done for 12 classes. Okay, this was a memory with the 12 class memory. That's why it's giving 0 score. Okay, let me run it again. Let me update my plan for VGG. It's time. Okay, let it run in the background. We finally see the result. So we have loaded this text. Okay. So to use NLTK package, first you have to import NLTK followed by this PUNKT. The Spunk is going to have a rich set of libraries that's going to support your NLTK, mainly for your the English languages. Apart from English, also we have few foreign languages also there. Okay, and also a few regional languages also it supports. So what are all the other languages it supports towards the end, I'll tell you. So NLTK, if you wanted to use the complete functionality, you should download PUNKT. So all the library you can import from using the prefix NLTK.tokenize import word tokenize. Similarly, we have NLTK.tokenize import sent underscore tokenize to do the sentence tokenization. Look at this this paragraph. I have some 4 to 5 sentences. The moment it look at the full stop, it will consider as a 1 sentence. But however, here first I wanted to show you the word tokenization. So how I use this word tokenize after importing this word tokenize, word underscore tokenize, you just pass your input text. This file is session 10 exercise 9, right? Session 10. Okay, session 10 exercise. You can try in your system parallel. This notebook is quite simple. Each and every task is just a 2-liner or 3-liner. See, the moment you say word tokenize, you pass your text, input text, you can, because it is going to return all the word values, the tokens in the form of a list format. You have stored all the tokens in the object tokens, which is the list form, and you can print all the tokens in it. What this word tokenization has done, it has tokenized the moment it sees a white space, it is going to tokenize that. So this is a raw text which includes all the a comma, punctuation marks, everything will be there. You can check the length of the tokens to find out how many tokens it has extracted. Length of the tokens 128. To standardize all the tokens, okay. See, one times at the beginning of the sentence, one of the token computer is written like this, and in the middle of the sentence, the computer is written like this, lowercase. Okay, this is uppercase and this is lowercase. If you don't standardize, okay, it will treat this as a separate token. It will going to treat this as a separate token. So all the tokens, the first and foremost thing is what in the pre-processing, I have to keep this all the tokens starting with the lowercase. Computer, this also computer. That's the tokenization. So how do we do this? Using NLTK, you can write a list comprehension, simple list comprehension you can write. Currently, all my tokens are in the tokens. For WN tokens, you just say that this is a normal string method. I can say string method. It's not even this is a part of your NLTK package. Even because we have read the entire paragraph and we already tokenized it. Just for the tokenization purpose only, I have used the NLTK package. But otherwise, this line is a very basic Python capability for the string handling. How your Python handles the string. For any string, suppose you have a string something like P equivalent to capital P Y T H O N. You are written like this. Simply you say P dot lower in Python. It is simply going to convert the string to lowercase Python. So we are performing this basic string level operation here. W dot lower for WN tokens. So each and every tokens, it is going to convert to lowercase. So the moment I run this, I show you words lower, all the tokens you can see starting from the lowercase. Even it is the beginning of the sentence, everything, every token is converted to lowercase. So earlier, what was the length of the tokens? The length of the token was 126. Because one token computer starting with the capital letter is counted as a separate token. Another computer written starting with the lowercase is counted as a separate token. Now, after converting all starting with the lowercase, this time if I check the length of the token, I think there is no such duplication was there. So 126 it's maintaining. So the length of the token is 126. Okay, how to we are going to remove punctuations, comma, all those things are how we remove. We will see subsequently. Before that, I would like to quickly show you how you can do the sentence tokenization. The same manner you can import from NLTK input sentence tokenization. Now you can check a length of the sentence. So totally you have 6 sentences. In sentences square bracket 0, if I print, this is the first sentence. Sentences square bracket 1, second sentence. This is the third sentence. Fourth, 5, 6. Totally we have got 6 sentences. Sentence tokenization is a very rare data preparation step. Most of the applications we have to generally we do the word tokenization. Maybe some raw text file when you prepare your training data set from the raw paragraph, when you prepare your input and output pairs when you create, no, that kind of situations, maybe sentence tokenization will be helpful for you. But most of the content based applications, classification tasks and all, we do the word tokenization. But however, and we are hereafter for the high end applications, we are not going to do this process manually. Okay, These are things that happens in the backend process. It just happens. Remove all the remaining tokens that are not alphabetic. So I give a condition from the words lower. Okay, if words is alphanumeric, other than alphanumeric, only the alphabet, anything related to the numbers, it is being removed. Okay, other than alphabetic or alphanumeric. Standalone numbers, do we have any numbers? Okay, there is no numbers. So remove remaining tokens that are not alphabetic. You can give this condition, words dot is alpha. It is going to return true. Only those token alone it is going to return. That is, I'm updating in words updated. Length of the words updated. I think you have removed the full stop, comma, and all. It is not alphabetic, right? Those things are being removed. Full stop, comma, and all. So the remaining we have from 126 is reduced to 112. Earlier step, you could see it's comma. It's not alphabetic. We have a full stop as a separate token. Again, there is a full stop. These are being removed. Okay, apostrophe. These are all being removed. They are not alphabetic or even alphanumeric. So after that cleaning process, our 126 tokens got reduced to 112 tokens. Okay. Now frequency distribution from the NLTK probability package. Generally, in any English sentence, the frequently utilized words will be like the, okay, is, was. Only the English stop words will be dominating. Actually, it won't return the actual content. Look at this. A has used 7 times, and used 6 times. We use 6 times. Off is used 5 times. The again. The is 5 times. Actually, here and is 6 times. The is 5 times. So my frequency distribution is going to give which token has been repeated how many times. It's just going to count the count. But with this information, it is I'm not going to use any decision making with this. It's a useless information for me. So what I need to do is I have to remove the English stop words. Then I ask this frequency distribution function. Then I can really understand what is the content of the paragraph. So before removing the English stop words, okay, I'm using this freq test function, the words updated. Okay, this is the words updated. So I pass this to the frequency distribution function, and this is going to give me all the frequencies. And if you print F directly, okay, if you print F directly, it is going to give the complete frequencies for everything with a dot, dot, dot. So you can ask this guy to give me the top 2 or top 5, most common 5 I'm asking. So most common 5 is written. Most common 7 if you ask. Okay, only at the this place we are getting the token which is related to the content. Actually, our content is computer vision, so pixel is the token related to the content. So first I have to clean all these English stop words. So to clean the English stop words, first you have to download the stop words from NLTK, nltk.download stop words, and you have to tell what is stop words. So you first you create a stop words English. It is going to return all the stop words in the English. So using the set function, you are giving some unique stop words in the English sentences and all the stop words. So it is going to have a set of all English stop words available in the English. You can print and you can see this. Okay, let me run this separately and I'll show you. I wanted to show you. Okay, if you print stop words, it is going to list all the standard English stop words in the alphabetical order. You could see about, above, after, again, against. You can see in alphabetical order. These are all the set of English stop words used in our English sentence. What you are going to give a condition, okay? If any of the token which is part of this set, you are going to tell we are going to give a condition, you are not going to consider it. So any of this. So how I'm going to pass this condition? So once again, I'm writing a list of comprehension. So first you map. First, W is mapped onto the words updated. That means your W will access one by one words. So first W is going to map your processed token. Now W will take computer, W will take vision, W will take this. So W is mapped onto your processed variable, which is a processed variable, words updated. So W is mapped onto the processed variable. And you're posing a condition. What is the condition you are posing? If not W in stop words. That means your token should not be a set of your stop sets. So you are giving a complementary condition, opposite condition, not W in stop words. Only those token which is not part of your stop words subset, that token alone you are retrieving. So your W will be preserved, which is not part of your subset. So if not W in stop words, you are retaining in the words filter. So computer is not part of the subset. That is the meaning. So if the condition is true or false, it is asking. If not W in stop words, not W in stop word means is computer is not part of the stop words. Yes, the condition is true. So you are, instead of asking whether this token is part of the subset, you are asking whether this token is not part of the subset. That is the meaning of this. So you are posing a negative condition, whether this token is not part of the subset. Yes, it is true. Computer is not a part of the subset, which is which subset? Your stop word subset. So condition is true, so it's preserved the computer. Next, it is asking whether vision is not part of your subset. Yes, true, it is storing it. But when the such condition is being tested for and the and all, it is asking whether the is not part of the subset. It's false. The is actually part of the subset. It will not retain the all the English stop words. It won't retain. So after filtering the English stop words, if you check the length of the words filter, you can see the length of the words filter is drastically reduced from 112 to 50. Originally it is 126. After removing comma, apostrophe, full stop, all those things, it reduced to 112. From 112, at least we have around 62 tokens were related to the English stop words. So only 50 tokens were very much related to the content. Okay. Now in the words filtered, now I'm going to apply the frequency distribution. Frequency distribution to the word filter, I'm asking the most common words, top 10 words. This is the top 10 words, or you can ask top 7 token because it's a very small text. Okay, soon I'll show you how we can apply for the rich corpus. Most common top 7 words I'm asking. Pixel came 3 times, picture token came 3 times, color 2 times, computer 1 time, vision 1 time. So by looking at the top tokens, we can understand this is the content related to the computer vision, talk something about the picture, pixels and all. Quickly, we run through all the steps for, okay, quickly let us run through all the steps for sample 2. Let me load sample 1 or 2 documents. Sample 2. You can see it's some mobile phone, isn't it? 7 nanometer dimensionality 6020 with a high efficient 2 ARM Cortex. Okay, it is a product description of a mobile phone. Okay, let you do the word tokenization. We'll do this filtering. Lowercase. After lowercase, you can skip the sentence tokenization. And then only alphanumeric. Okay, English stop words, we have to remove the English stop words. Next step is I need to remove the English stop words. So let me get the top 7 frequently. Okay, dual support RAM dimensionality high efficient. That means nowhere they have used mobile. There is no token related to mobile. Because it is a very short paragraph I have taken it. So let us try to do this in a rich corpus. If you wanted to do this thing for the rich corpus, there are some standard corpus are available in NLTK. These are all some popular corpus available in NLTK. You can download separately, like NLTK download, Gutenberg, Genesis. If you wanted to do something on web related text, okay, NPS chat, each category wise they have given some corpuses are available. I'm downloading those rich text corpus from NLTK. Meanwhile, I'll just show you, if at all, if you wanted to do some fine refinement, say for example, if you wanted to set some condition, like you wanted to retain the token only the minimum, the length of the word should be, okay, you don't want to have a 2-letter token, or you don't want to have a 3-letter token, some minimal cutoff if you wanted to set, that is called as a fine-grained selection of words. Again, that I'm applying it manually. If length of the word is greater than 3, that alone I'm retaining. That means any token less than 3 length will be filtered it out. It won't be there, part of it. See, now the length is total length is filtered word is 70. After 5-grain selection of words, let me check. Sorry, not this guy. Yeah, correct. This is from 70 is reduced to 63. That means it retained only length of the word above 3. So 4-character word alone it is retained. So these kind of customization, if your application demands, you can free to use it. Also, NLTK supports some English regional language. I told you, right? So NLTK corpus Indian words, if you type, okay, it supports Hindi language and Telugu supports Telugu. Some few regional Indian languages your NLTK package supports. You can see the documentation page, which are all the local language it supports. You can check it. Okay, I'll talk about this little later, TF IDF factorization. First, we are seeing focusing on the basic level process. This is what the high-end API I told you. Okay, this is the high-end API. If you directly use this high-end API, in the back end, automatically all these processes will be done. Directly, it is going to give you the numerical representation. But before we use this higher end API, what is going on in the background is these are all the steps going on in the back. Now, let me load any of the rich corpus from this. You can directly load a text 1, text 2, text 3. These are all a very, very big file. Say, for example, text 7, let me load it. Here I am loading the text 7. Since it is a built-in data set, for the built-in data set, you have to follow a certain protocol. w.translate table, it is being kept in the form of some different structure. We are bringing to a form of a tokenized version. So this is the standard step we do to access, to remove the comma punctuations. So import string. To remove the comma and punctuations from the standard text of any of the text, if you wanted to do the script word alone, you can extract. So since it is being stored as a built-in data, the moment you say w.translate table with this condition, a mapping w is mapped onto text7, directly it is going to return in the form of the token itself. Directly you can get this words underscore strip. Directly you can get the token. So the tokenization part you can skip directly, because this is being kept as a built-in file. Manually we don't apply the tokenization step. Without doing the tokenization step, directly just remove the punctuation mark alone, and you can start reading the tokens. So this word strip, okay, you have got the words from any of the text. You can extract that, and the remaining process you can do converting to lowercase. Look at the length of the words. Now it is a very rich corpus. You can see how many tokens are there. It's a 1,06,676 tokens are there. And after running through not alphabetic condition and after removing all the English top words, now the length of this corpus is reduced to 48,561. And then I wanted to retain only the token which is length 3 and above. So the length 7, okay, this is the text 7, fine grained words 36,184. For this guy, if I print the most common, look at this, the word million is used 383 times, company used 260 times, market 186 times, stock, trading, president, billion, program, could. So this looks like your stock market, right? Your Wall Street Journal. Wall Street Journal stocks talk about your. Any other article, famous article you would like to read? Let us see the chat corpus. Chat corpus. It is part of text file. Chat corpus. What is the content of the chat corpus? Let us check. I think chat. You can see this is a chat message. Hello everyone, thanks girls. Maybe we'll see 20, top 20. Top 20. Have you heard about this Monty Python and Holy Grail? What is the speciality of this? Anybody heard about this Monty Python Holy Grail? Actually, this is one of the comic television series was going on inspired by this book. That popular television series was going on. The founder of the Python was developing this software. That was the time he was wondering what name I could give for the software. It's just a momentary thought that his kid was watching the series, Monty Python and the Holy Grail series, the television. Just quickly strike his mind. It looks very catchy, and everybody can easily understand and can remember it. Just a momentary thought. He just he told one of the interview during that time. So what was the thought process when you named this software as a Python? He just told that he got just inspired by this television. Okay, let us see the content of that Monty Python. Only those people who watch that comic, either they read that book or even they know some characters, you can be aware of. Okay, see, I'm not aware of those characters and all. So these are Arthur, Knight, for the these are all some of the things related to that television series. Okay, you can do it for these kind of processing for the rich corpus. You can do just for the practice purpose. You can use any of the corpus and try to manually compute certain things over the tokens, and you can play around it. So moving forward, we'll be using some high-end APIs like TF-IDF vectorizer, or count vectorizer. We'll be using count vectorizer. Then another popular is called word2vec. 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 So I'll tell you the usage of these guys in the next session. To the modeling context, actually, how I have to prepare these tokens to the model. How do you have to prepare your data set as an input to the model, to the context of the modeling? I'll give the introduction about the three common TF, ID, F vectorizer. Earlier, before this, count vectorization, and the third one is word2vec. Out of which, this is very popular in the recommendation index. Okay, this is very popular in the recommendation index. Your e-commerce, most of the e-commerce portals use this representation, content based. And this kind of representation is very popular in the language models. Okay. I just wanted to quickly show you some flavor of a spaCy package. Okay, spaCy, we'll get some quick exposure to spaCy, and so again I'll come back to this, how to use the TF-IDF and all, and how to comprehend the meaning of this TF-IDF and all those things. We'll revisit this notebook, don't worry. So I would like to go to spaCy package. I would like to give you some idea about text pre-processing using spaCy. As I told you, spaCy is preferred to do some high-end operation, not for basic level operations. Mostly for basic level operation, NLTK is preferred for the data cleaning, to remove these punctuations, full stops, command all. And having said that, spaCy also having these basic level operations also spaCy supports. But on the contrary is not true. That means the NLTK is one side, spaCy is another side. Okay, NLTK is highly preferred for the low level data preparation, low level process. spaCy is highly preferred for some high level application, which includes certain ready-made tasks also. It includes, say for example, a named entity recognition. Already you are aware of NER, named entity. Suppose you give some sentences, your functionality will recognize which is the noun. Is there any geographical location? Is there a company name in the sentence? Which is the company name? Which is the person? Which is the geolocation? Address part of the text. So that is called the named entity recognition. Also, in a particular given sentences, okay, spaCy has a package to tell that in a sentences, what is the meaning of this, which is a subject, when the subject comes, what is the pronoun, is there any adjective is there or verb is there, whether it's a singular or a plural, everything it is going to tell you. So parts of speech, we call in English grammar, we call this as a parts of speech, right? These kind of a high-end package the spaCy provides. On the other hand, your NLTK does not have these kind of a high-end applications. Basic level processing you can do. So having said that, spaCy, even though spaCy supports a high-end application, spaCy supports the low-end process also it supports. But all you need to know is the protocol. What is the way you have to download and how to use it. Remember, whenever you wanted to use a spaCy package, you have to load a spaCy object English core to support the English core. There in NLTK, how you downloaded PUNKT, right? PUNKT package. Similarly, I have to load this English core web underscore SF, and you can name this in any name. You can name this. Okay. So hereafter, any text you define, whatever the text, even you define a small text like this. How are you? Okay, how are you? Or a man standing near a building. Some sentence you define, and you kept this as a text. Okay. If you wanted to convert this your text to spaCy understandable format, whatever the object you have created for the spaCy, my spaCy object, using that object name, okay, first of all, you have to wrap your text using your spaCy object. What is the name I have kept here? My spaCy underscore obj. This is my spaCy object. Whatever your incoming text, first of all, you have to wrap it up as a spaCy object. So you have to pass your text here. Now I'm going to call this is my text doc. Okay. Now you can start processing anything with this text doc. Directly, you cannot apply any spaCy functionality like this without typecasting this as a spaCy object. That is the key point you should be aware of. That's the basic step. So the moment you load the previous exercise, we load two samples, right? Sample.txt and sample2.txt file. And we have loaded that file in a text variable. The text variable directly you cannot apply any spaCy operations. To apply spaCy operation, first of all, I should typecast it using your spaCy object. Then your text is ready to use. So that is I have represented here. Currently, what is there in the text? Same, the mobile phone description, right? That is there in our text. Let us try to do some English stop word removal, or even I just go back to the first text, computer vision text. Let me load the computer vision text. That is sample.txt. So this txt file, this file, I'm going to define this as a spaCy object. So only the raw file I'm taking without any pre-processing. So the txt I have to typecast as a spaCy object. That's the first step. Here. So hereafter I need to process. This is my text object, which after typecasting, text doc object. So now what I do, a token in text doc object. This is the tokenization process. Actually, your entire paragraph is being loaded here. This text doc object is actually the entire paragraph actually. Let me take this line separately. Okay, to the next cell. Simply, I would like to show you what is there in text doc object. The entire paragraph. Okay. So there in NLTK, we have used the method called word underscore tokenize. But here, how you can do directly, you are mapping a variable called for token in text doc. Entire paragraph, you map this variable token, and you are simply saying that token.text. That's all. So you are calling a token.text will actually extract the tokens from the given document. The way that is, your method is different. Okay, the functionality and methods are different, but the objective is same. Now you can see it is tokenized. These are being tokenized. Same way you can do it like now I'm mapping my sent in the text doc object. This time you are going to say dot sends, because my sent is you have mapped on the text to object. While you are mapping itself, you are saying that map on the sentence wise mapping you are telling here. So while you are mapping itself, you are saying that sentence wise mapping. So your my sent is automatically going to extract the sentences, 6 sentences, the same 6 sentences. And the way to use a stop word removal, first of all, you have to create one stop word subset, right? There we have created a stop word subset in a different manner, but here spaCy language English stop words dot stop words. This is the keyword argument you have to pass, and you have to define that as a stop words. You wanted to see what are all the stop words it contains, because your NLTK stop word may be slightly different from your spaCy stop words. Not necessarily both should overlap. Maybe if 1 or 2 stop words your NLTK package might miss, your spaCy may have. I think spaCy has more refined stop words corpus than NLTK as of my knowledge, because the spaCy was developed in recent times than NLTK. I don't think NLTK in recent times they have upgraded it. So using the stop word, okay, the same negative condition I do, whichever the token is not part of your stop word spaCy stop word list, it is going to extract. But still we have not removed the command, all right? You could see these commas. So to remove your commas and punctuations, you are passing multiple conditions. If token is a punctuations and it's not part of the stop words, you clean multiple condition in one shot if you specify, and you filter the cleaned tokens, and you pass there we use frequency distribution. Instead of frequency distribution, here the alternative here is counter function. Only your library name is different from collections import counter. This counter is doing the same job of your FREQ-DIST function of your NLTK package. So your counter you operate on the cleaned words, and it is going to give you the word frequency. Same manner your invoking is same. So dot most common you are printing, and let us print the most common. Print COMMON common words. And this is just a fancy bar plot representation. Before we see the bar plot representation, first let us see the actual words. So the stop words it is showing. Okay, top 30 words, maybe top 10 words alone I print. Is the top 10 words. So this is being represented as a bar chart like this. So picture which are the words tokens appear very frequently. I represented as a fancy. So these functionalities same as your NLTK, no big difference. Just the matter of the functionality is different, but it has a similar set of operations. Whatever the operations you have done using NLTK can be done using a spaCy also. More than that, your spaCy is very well celebrated for 2 things. One, for parts of speech application. Number 2, a named entity application. Your text doc object, that means your entire paragraph, Okay, your entire paragraph it is going to consider now. So for token in text doc object, it is going to tag each and every word. It is going to tag with the parts of speech, and is going to explain it also. So you're going to you're telling the spaCy object to explain the parts of speech, whether it is a singular or singular present tense, or what it is, what is the context in terms of the grammar. So spaCy.explain your token tag you are going to. So token tag with the token parts of speech. This is the token, okay, followed by your token tag and token parts of speech. Your token parts of speech is a computer is a noun, and it is explaining whether it is a, what is it talk about. It is a singular. So each and everything it is going to talk about each token. It is going to talk what is the meaning of this. Wearing is a verb, present participle. So any application which demands this kind of retrieval, your parts of speech is one interesting application of just a single line you can retrieve this. So token by token, it is going to give you the meaning of what is the grammatical context of a particular token. Standalone, we generally early days it was very appreciable, but afterwards in modern day it loses the significance, because the reason is in modern day we have we started using more sophisticated models and all, packages and APIs and all. In this is being automatically taken care internally, and moreover these kind of operations people, they were doing it without the support of models and all, because actually your model is going to learn everything. Okay, in model is going to understand the sequences. Based on the sequences, it is going to draw some attention over after the subject, whether this verb comes. This verb is actually your subject is undergoing this action. Everything your sequence modeling is going to capture the pattern, not in an explicit manner like this. We are not actually explicitly, we are going to tag this is the subject and this is the object, or this is the verb, or this is the adjective. We are not going to tag it. But early days this was quite useful, but in modern day we have more sophisticated deep learning model which is going to very well understand the words sentences and going to make a contextual decision. In modern day context, this is not being celebrated much, but however you can treat this as without, suppose if somebody wanted to do some quick understanding about a particular paragraph or token by token understanding without the support of any artificial intelligence model, maybe this standalone this parts of speech application may be helpful. But understand in moving forward, your language model very well understand all those things. We don't explicitly teach the model, hey, this token belongs to subject, this token belongs to a verb, this is a singular verb, this is a plural verb. That way explicitly we are not going to teach. Another interesting application is what the named entity recognition. Again, we have a built-in package, but we can construct a model to train these things using our sequence modeling. We can develop a model to understand which portion is the as a person, which portion is the company name, which portion is denoting the country name. We can, during the training process, we can actually build the model. Not only for that, you have to give some training samples. So this is my input sentence. For the input sentence, you have to tell what are the things you are going to label it. So you wanted to label. So the person name is the Sundar Pichai, and the company name is Alphabet, and the location is California. So likewise, you have to create multiple sentences and you have to tag it. So for the named entity recognition, so which token belongs to what, you have to train the model. Again, you have to train some sequential model to learn this pattern. So any of the production level data, when you present your model, when you do the model.predict, whatever the way you have predicted, and it is going to tell that, okay, this is name, and this is the company name, and this is geolocation. So using our sequence modeling, this kind of application also we can construct. This is part of a named entity recognition application. But spaCy provides that as a handy package here. So all you need to define your text as your spaCy object. First, you have to typecast as a spaCy object, and you have to process this sample doc. For ENT in your sample doc object, e.ents, to indicate you are going to do the named entity recognition. So starting character, which are the things you wanted to print, you can specify. First, you are saying that starting character, you print the starting character, end character. That means Sundar Pichai is it is identifying it is a name. So which is the starting character is the 0th index, and the ending character is the 13th index. So it is indicating it is a person. So you're printing what is the label. The label is person is the label. Similarly, organization is the label, country is the label. And you're explaining, like a parts of speech, you're trying to explain, right? It's singular or plural. So it is explaining. So during the training process itself, it is being taught in such a way that it is an influential or it's a fictional name. Like that, it is being trained in. It is saying it's a person, and it is being taught as it is saying that it is a fictional. Maybe it is not a fictional character, it's a real life character, because whatever the spaCy object, it is being trained on the some sample reference data set, whatever it is. It's not so robust as our modern day deep learning language models. The volume of corpus it is being trained. It's a very preliminary model, or we can call it as a baseline. It's a very baseline level model. Don't expect your large language model level accuracy. These things are going to do it. Very basic level you can do, because you know, these are the functionality was available 6, 7, 8 years before itself. But all the very sophisticated large language model emerged in recent years, last 2-3 years only. GPT model and all emerged in GPT-3 has been emerged. So GPT-3 level accuracy we cannot expect in this space. Okay, it's a very baseline level. Definitely, it is going to recognize some basic level identity is going to recognize. At least it says the person, but maybe the explainability is not so accurate. Like it is saying it's fictional. So if you wanted to have more refined representation, of course, we have to prepare our own training data set, and you have to train language models. You have to configure your input and output, how you wanted to configure your input and output. So first of all, we have to figure it out whether this comes under one-to-many or many-to-one or many-to-many subset, and how I have to prepare the input and output. That is what nowadays people are learning this as a prompt engineering, prompting. So how do I prepare the input sequences and how do I prepare the output? So, but actually we are going to learn in a raw fashion. We are going to learn for the different architecture. How do we prepare the input output pairing? For one-to-many, how we are prepare the input output pairing. For many-to-one, how do we prepare the input output pairing? And many-to-many, how we are going to prepare the input output pairing. So this kind of application which comes under, okay, strictly speaking, like a many-to-one, like a classification task, model has to understand this sequence. Okay, it has to understand the sequence, and you can train the model to predict something like a multi-class output. Multi-class output in the sense like your sentiment analysis. Okay, using your feedback type of model. Say for example, using LSTM model. Suppose this movie is a great flop. Okay, if it is not a recurrent model, okay, your feed forward model will focus only on keywords. Okay, even though we have a flop token is there and great token also there, maybe it won't give you, okay, maybe it won't give you the best probability score for the sentiment, whether it's a positive sentiment or a negative sentiment. It will get confused. Model will get confused. See, gray token also there, a flop token also there. So maybe you get maybe a negative review. Assume that it is going to give you the negative review. With a probability score of 60%, it says it's a negative, and 40% chance as a positive. But as a language model, it is going to understand the sequential context of it. Your language model can better give the opinion, maybe with a negative probability score of maybe 80%, with the positivity is 20%. Sometimes you have here the sarcastic comment like this, right? This is a classic example of sarcastic comment. Many sarcasm will say that indirectly you are injecting a negative comment over that. But like a pricing format, you start with the pricing format, but finally actually it is actually explaining the negative sentiment of the sentence. So your feed forward model multiple times, it works good job if the sentence is not sarcastic. Okay, basically just look into the keyword arguments and make a decision. But if you wanted to really make comprehend the meaning of the sequential context, the meaning of the actual language sequences, maybe we have to train a language model will outperform a feed forward model into this context. So you can try multiple sentences and see the level of accuracy or the spaCy provides. It's a very basic level. But 7-8 years before, this was it was a big thing. 7-8 years before, those time when spaCy came up with parts of speech and named entity recognition task, it was quite appreciated, very well appreciated. At that time, NLTK was not having such functionality. But now in a modern context, we know that this is very simple, and even in modern day context, we have more sophisticated models can do it. A sophisticated deep learning model can do it. So we can treat this as a baseline level performance. For the baseline level performance, it's far better, right? It's recognizing a company name fairly. It's in the sentence fairly. It's recognizing its alphabet is a company name, and California is a country. So not bad at all. So any other sentence you try and see how it is performing the named entity recognition. Which company, Vijay, you are working?
Math company.
The math company. Maybe based on the incorporate identity, it's recognized the company name, I guess. Of his hometown. Hometown, Salem?
Karur.
Karur, okay. Vijay is a person. Okay. By default, it tells every person name as a fictional name, because mostly this spaCy is being trained with some corpus of the Harry Potter kind of the corpus. Most of the novels, comics, these kind of the names is predominantly it's being trained. So it says the Vijay, the name, it always says it like a fictional name. The data scientist of math company, everything it is saying that. Okay, because the moment it sees the INC, it puts full stop for, okay, here the company name stops. Maybe without this INC keyword, whether it's recognizing or not, we'll check it. Okay, up to this, it's saying it's a company, but it's not so precise. Okay, strictly speaking, the math company should come. And it's Karur, it is identifying as a city name. The whole thing it's stating as a company name. So that's why I told you it is not so accurate. Base level performance it will give you. So moving forward, we'll be learning how to. No, we are directly using this as a package, but in the subsequent session, you will be learning how to build a model for this kind of application. How you can build a model. Named entity recognition comes under which category? Similarly, a language summarization, as mentioned by Jeba, she wants to give some paragraph output. She wants a short summary. Sentiment analysis comes under which application? And I give some key tokens like a moon, a woman, love. I just give some key token. Okay, my language model is going to generate some nice poem using these key tokens. Using the key token moon, woman, love, it is going to generate a nice poem. You can train a model. So what kind of problem can fit into which subset, and how do we prepare the input output configuration according to a particular type of language modeling? For that, we got a brief introduction to how the basic level text preparation we understand, but this is not the complete picture. Okay, the real picture would start actually coming from TF-IDF vectorization and word-to-vec representation. That is actually it's going to convert your data into a numerical representation. How your language model is going to understand that numerical representation, how your model is going to learn the sequence. That is we need to learn. For that, we need to learn the mathematics of RNN model. So don't worry, it is not going to be completely upside down mathematics. In fact, we are going to use the same gradient descent rule, the feed forward, and we are going to propagate the error back. But additionally, we are going to, only my hardware wiring is different. Okay, the way in which your model learns and all, it is going to be the same. But because of this hardware wiring, this feedback loop, this hardware wiring, it is gaining certain strategy in memorizing the sequence, past sequences. It has some interesting, gating mechanism and all, and how it is going to memorize the sequence of the pattern. So feed forward flow, what happens in the feedback flow, while you are propagating the error back, you have to adjust the weight of your feedback loop weight also need to be get adjusted along with other weights. So this is one extra architecture you are going to learn. What is the role of this extra architecture? So how this special architecture is going to give the capability of the for the model to understand the sequence. So in the next session, we are going to understand the complete mathematics of recurrent neural network, and also you will soon realize what is the drawback of using the actual recurrent neural network, and how we are overcoming the recurrent neural network drawback using LSTM model, and of course, like LSTM and GRU, I can say like a brother and sister. Okay, who's the mother for them? RNN is the mother. So these guys are kids. Okay, they got both guys got the inspiration from their mother, some characteristics from the mother, but it has some no, like generation differences there, right? So they are more active than these guys. So what is the capability these LSTM and the GRU is going to have? People think that most of the youngsters, they believe that, okay, LSTM is being used for all the application. Let us stick on to which is most recent. They stick on to it. But still, some people are using GRU also, gated recurrent unit also. Few applications people are using it. Okay, may not be GRU is not so popular in recent application. Doesn't mean that completely I need to ignore this. So still some really some application demand this. Okay, to put it in a bigger picture, see, we have not learned anything on these guys. I just giving a superficial idea. Okay, I can say this is more complex. Okay, more complex and difficult to scalable. And I can say this is a less complex, easy to scalable. Scalable in the sense in the large volume. If you wanted to scale your model to a large corpus, nowadays people prefer the less complex version of LSTM, which is GRU. And in terms of pipelining and scalability, GRU is highly preferred, but LSTM is a bit complex. Whether are we doing a very good trade-off for this complexity? What is the benefit we are going to leverage for this trade-off? Whether it's a reasonable benefit or not, it's a debate. So once after understanding all these entities, you will really appreciate the pros and cons of LSTM and GRU. Okay, timing, please understand. These are all the components you are going to learn in the subsequent sessions. After learning, we'll be doing some interesting application in each category. We are going to do one interesting application.